Oh, that says we're live. I guess what's going on? Memes here. Apologize, I'm going back and forth. I think I probably do need to update some things. It's saying, well, your license expires today, so we have like 4.5 more hours where we can actually do stuff. So what are we doing today? We're going to continue with our little computational working session over here. Let's go over here. Where are we? Look dangerously the entire screen. Here we go. All right, let me cover myself up with something. All right, we'll go over to yes, my integration. I'm assuming this is why it's not working. If not, then I will submit a ticket because I often submit tickets when it gives me answers I want and I disagree based on our knowledge. Okay, let's go over here to our notebook. All right, so we're going to attempt to use the notebook assistant again. Let's try something. Let's open a new notebook. We're going to test something. Okay. So what we're going to do is we're going to go computation that we may have done on Wolfram Alpha itself. It's big in this so we can all see. All right, so we're going to put our computation. We're going to literally try to do the lazy thing. We're going to have Wolfram Alpha do the hard work. Okay. We got the full Wolfram Alpha results. Okay. Now, since we have all the stuff here, and it can output the little code and stuff, let's use our little notebook assistant. Okay. So let's ask some magic words. All right. Please take our above computation and turn it into a nice grid. A nice grid with proper labels. Let's see what we got. It has the computation. It should be able to... Okay. Okay. It's going through. It did some iteration. All right. That looks pretty good. Let's see what happens. Okay. All right. All right, that's very simple. Okay. Speed of light. All right. Well, that to be fair, that's speed of light squared. Please display the value, the numerical value of the Higgs mass and the speed of light with proper dimensions. There we go. All right, so it should just be a display thingy here. Okay, speed of light, blah, 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 come from wavelength, okay. Let's see. Okay, so the quantify function, okay. Oh, it really does not like these quantities. I got errors. Please help. That's the thing. If it literally can read the notebook, it should be able to likely do. Okay. Yes, yes. Let's just do GeV c squared. Let's see. Yeah, yeah, okay, gigaelectron c squared. It I'm not gonna lie, anytime you query the database itself, these are things that have been yes, yes, it's still an issue. Okay. Please just use the shorthand GeV divided by c squared. There we go. Now, ideally, it should be able to fix this, because I know chat can fix it. The question is, can we get this up to snuff right now? Just because it had, at least the last time I checked, I don't think ChatGPT could read Wolfram notebooks or something. I mean, you could take pictures and everything. Okay, boom. All right, it did that. Let's see. Higgs particle. I'm just wondering why it's. I know it's making up some digits there for at least the past couple of them, and I know that the Higgs. That should be 1.8 Higgs particle. Yeah, so they have it there. Let's see. Convert. Let's see. Star. Higgs particle. Can we please display the full numerical value of the Higgs mass? All right, we're slowly getting through it. Hey, Charlie. That's a free. I know. Here's the thing: people got busy. You're doing a working session, computing curvature. Who really cares about that? It's the only person that cares is the person that happens to really care, that happens to know that this is a thing, and then decides to click. You, Charlie, clicked here. Now, again, I'm not going to say this is going to solve anything, but it's just we're trying to go through logic, because I can make claims, and that's wonderful and everything. I can say nice words, and we have to follow whatever logic. And I'm just following my noob mindset. I'm like, all right, I do all this stuff. I have chat make the little cute spherical cow with an ultra instinct background. I'm like, cool, moo. All right. The question is, well, if that had been come back with roughly about a meter-ish and its scale of curvature, I'm like, that's interesting. That seems to be the scale that we exist, that we kind of create our meter on. Because right now we're using the meter, and it's like, yes, it was originally the North Pole to the equator by root of the Paris Observatory, of course, divide by 10 million, because obviously, duh! Eventually we refined it for a while, and actually good while. We kind of linked the kilogram and meter to water. Why? Because approximately 1 cubic centimeter of water is 1 gram. It's literally like back in grade school, how you'd have like, all right, you got a row of 10 blocks. All right, you do 10 more rows like that, you get 100. And then if you do 10 more up of those rows, it's like, all right, now you go to 1,000. Because guess what? If you take 1,000 of those grams and you build up 1 cubic meter, it's going to be about 1,000 kilograms. I mean, you could argue that maybe that's a better scale. I just don't really have the evidence for that. But right now we're using to try to minimize our fudge factors. We basically have our second defined as whatever the oscillations within one cesium 133, blah blah blah, and then you relate that to the speed of light. There ends up being like a factor of 30 or something there. Long story short is that's how we now define it, by the hyperfine transition frequency of cesium 133. See, like for quick random language model fill in. As soon as I got to that term, I just spit that out. I really wasn't thinking. I'm like, hyperfine transition frequency of cesium 133. That's just kind of like one of my go-tos. It's kind of like the dog sat on the mat. It fill in the blank, which is an interesting thing, and then makes me question my own consciousness. If that, I don't know if I'm conscious. Who knows? Uh it's. I appreciate. Hey, everybody needs a fan, Charlie. No worries, man. Um, we're gonna get into the good stuff. A lot of this is just me fighting with technology because I'm an old fogey. Um, let's not belabor the point. All right. Do the thingy that I want. Can you give me the extra digit? Well, line up. Okay, now it's just quoting it. I have errors. Please help. I'm literally, all I know is a lot of times I'll listen to Stephen Wolfram in some of these like computational sessions where he's doing his CEOing and stuff, and literally he'll be going through some like function. I'll be like, help! And you got all these brilliant folks around him. It's I can see why a lot of other people may not want to stream like live working sessions because a lot of things go wrong. There's a reason why a lot of times people folks say you don't want to see how the sausage is made because it can be infuriating, but it shows the effort that goes into something. And I think, God, there's a who knows. All right, Illy, I I am not a professor. No. I'm a crazy person on the internet attempting to be a science explainer. That's what I'm not gonna qualify that with anything. Full disclosure, I would love to be a professor a long time ago. I'm like, I wanted to study psychology. I would love to be like a psychology professor back in the day. And I realized how much education in school I would need to continue to go for. Well, actually, once you finish undergrad, I guess it's not. It was a lot. It was a lot. I'm like, I don't think I could. I have friends that have done it. I have friends that have gotten their PhDs and everything. It's just, it's a lot of work. It's a lot of work. Unless that is specifically what you want to do and how you're going to go about your life, it's a tough thing. That was a long, bloviated answer. I apologize. The answer is no, I'm not a professor. In my wildest dreams. But can neither confirm nor deny that point, Dexter. Very astute. Very astute. Kelly Fisher or Kali Fisher? I know Kali. Kali. She's put out some things before. We've had her on the program to discuss neutron decay cosmology, and to be fair, that I might disagree with a particular geometric form, but again, who frickin' knows at this point? Maybe we'll never know, but I don't know. I try to channel a little bit of Stephen Wolfram and like the generalized optimism. I'm like, we should be able to figure this out. It could be hard. Who knows? Maybe literally some of the biggest answers to our questions are literally sitting right under our nose. We may just be gleaning over them. Can't say. Oh, no worries. No worries. Again, I'm not going to confirm or deny that, but it's all right. Yes, welcome. No, it's all right. Keep yourself safe. Do not feel like you need to participate, or I would discourage anyone from participating if it's going to make you unsafe. That's the thing. Take care of yourselves first. All right. Let's see. Where are we? Oh, no worries. It's Bill. Yes, amplitude. To be fair, it's Bill is part of the inspiration because I was looking through some of his things. I'm going back and forth. I'm kind of arguing with Chad. I'm like, all right, I don't know. Again, who knows what actually is the case? There are certain things that I think Bill just needs to state right off the bat. It's like, all right, we're working within a holographic framework, assuming that our universe, is inside a black hole and stuff like. He just needs to state that first because and again, he gets really excited and stuff. And again, he's not a physicist. He was like, literally a meteorologist. He was one of the guys that was like working for Ford and basically because he full disclosure, him and his wife Kathy, wonderful folks, put me up for the evening, bought me pizza and stuff before I did my little journey back across country by way of Canada. Um, Something came up on one of the physics monastery things this past week, and Echelon brought up. It's like I kind of think something like because I was showing a little calculation for a potential curvature, and we'll go into that. And he's like, I think like we just got to have like some information on the boundary, and he's saying, talking about kind of the holographic principle. I've been gone through some of Bill's stuff, and like, all right, I'll ask chat some things. I'll go through, and I'm like, okay, for me myself, and again, I'm not a mathematician. I realize I should be doing a lot of pencil and paper and stuff, but at least Wolfram Alpha as a dimensionful calculator, if I can go through and at least reproduce something like that, I'm like, I can at least try to get an intuition for what's going on. I also feel like as somebody that did go through school and used a TI 83 or 83 plus or whatever it was and did whatever the finance homework and calculus and stuff. And to be fair, I did take modern physics for like a week in college. I didn't realize it was supposed to be a senior level elective for folks that had taken physics 1 through 3, all the labs, thermodynamics, and electromagnetism. I just show up there as a business student. I'm like, I like science. The professor, he was actually willing to work for me. I did need to drop the class for a graduation credit for more of an entry-level science class. It was like exploring the universe or something. Something solar system calculations and stuff. And I don't know, once you get exposed to like high energy particle physics and calculating like a proton going 0.9999999 times the speed of light. And actually, like, I was actually able to do that because like that piqued my interest. They were talking about lattices for some other things, and to be fair, I didn't know what's going on. I'm just like something crystals, oscillations, frequencies. Yeah, I didn't know all the terminology, but at least being able to go through things, I see why there's exercises. And as convenient as it is to have Chat, Gemini, Grok, whoever, do all the math for us, at least going through and be like, all right, I get this number. Let me take this other entity with these dimensions. Let's divide, because that gives you an intuition. So it's, what is it? I got like this. Hold on. I removed myself from the party. All right. So, all right, not the cat stuff, but all right. Here's the thing. Like even on this past Sunday's Demystify Sci Sunday Salon, it's like, all right, they were talking about momentum a lot. Okay. So if you've got momentum is your mass times your velocity. You got something with mass. It's got a speed in a direction because velocity has a direction. Okay. So velocity is you pick your direction. It's a length per unit of time. You got mass. This equals momentum. And a lot of times I think the general point is somebody was coming at it from, well, to be fair, there is angular momentum. And if you look at Planck's constant, that has the dimensions of spin, angular momentum, whatever that may or may not be. What is that? And they were talking about momentum, and then they were talking about locations. It's like, okay, that's cool. And again, I don't remember the exact thing in the context there, but I think to help folks understand or try to grok it, pun intended, a little bit better, you got a momentum, you got some stuff, got directional speed. Okay, cool. Now you need to add spin. Okay. Well, if you got spin, there's got to be some other movement going on there, so you got to traverse another length. You square that, and those are the dimensions of action. It's Planck's constant. It's literally like Planck mass, the Planck length squared, divided by the Planck time. The only reason I know that is because I've gone through the computations enough. And the benefit of, if you're just using Planck units, they're all technically 1. They might be a maximum 1. It might be a minimum 1. But ultimately, they're 1. There's also something fun I think will think we'll do a video maybe on that tomorrow. Maybe I'll actually use the board. We'll see. We'll see how this goes. I need to fight with technology to make some more progress and everything. So, okay, I don't think I was completely going crazy the other day about like the little freeform input and everything, because I think I just need to update my version. Okay, so let me bring this back up. All right. Sorry. Went on my little 5-minute thing to go back to what Bill was saying. Having practiced some of the calculations that he was using, after Echelon said something about information, like, wait a second. I've been playing around with the Bekenstein-Hawking radiation, aka the Hawking photons, because black holes, apparently, according to some folks, again, hasn't been proven that I know. I think they may have shown unradiation, which is essentially just a movement through like space-time, kind of doing the same thing. It's this weird thing that to an observer accelerating at a high enough velocity or rate, apparently they will just view things as kind of weird stuff. Somebody viewing them will see them essentially on fire, or like they'd be emitting all this energy. They may have actually... I need to start doing a science news show rather than just doing all this stuff. So one, I can keep myself up on there, and I think maybe we actually do need some more science journalism or something that's... Full disclosure, I joined Fraser Cain's Patreon just because I'm like, it's like, well, there's a lot of AI stuff going on. I'm like, he's one of the folks that I see out there that's doing, from what I can tell, journalism. He may occasionally express his personal opinion, but he'll usually state that. It's like, here are the facts, here's the understanding, and it's refreshing having news. It's not telling you what to think. It's like, hey, here's what's reported and stuff. Make up your own decision. But, oh, yeah, no worries, Illy. No worries, Illy. Again, I would love to say I'm that smart. No, I do not have that much education stuff. A lot of this, people are curious about things, and a lot of times when Stephen Wolfram touched upon this earlier, I'll probably clip that out or something at some point, but in a live stream, he was talking about like back in the day when you had the days of Faraday at the like Royal Society in London and stuff. They literally had like Faraday's lab and a big auditorium next to it. He's like, well, basically on Fridays, Faraday would just be like, hey, here's an experiment. Here's some magnets. Here's a candle. Or he's showing the stuff to folks that were actually interested. And I think, was it Stephen Wolfram had said at one point, he had given some talk on cosmology or something. And apparently he got some folks may have leveled some criticism. It's like, oh, it was too simple or something. One of the greatest compliments that he got was after he gave his talk, just your average Sally Dirker James, just kind of like a person that wasn't a professional scientist, came up to him. He's like, listen, I just want to let you know, like, I enjoyed your talk. I actually understood it. And it's like, do we have to communicate on ways that people don't understand? I mean, like, it's not really communicate. And I understand there's some things, if you're showing all of these matrices and stuff like that, people, very often if it gets to a point where a person's head hurts, people just shut down. And then, I don't know, is it kind of like a level of attrition where it's like, who's going to pay attention long enough to actually say something, or is... I don't know. I'm sorry, I'm rambling here. Okay, so Charlie, the whole thing about the spherical God cow is literally... What's the best way to say this? Let's use the board before we get back to the stuff. So number one, it's a meme. It's a meme because it's taking the concept of the quote-unquote God particle, which I believe was originally a book title from a Nobel laureate that was given not for accuracy, but to help sell more books, because there's the old adage that every time you mention God in a book, you're going to sell more copies. For every equation you have, you're going to end up having less copies sold there. So it's the whole concept of you get something like, don't mind me, I'm using my erase. Oh God, using it to prop on my lap. All right, so I got that there, got that there. All right, that's all concept. It's like, all right, you got the Higgs, which to our knowledge, it is purported that the Higgs is the one known elementary scalar field that is everywhere. Now, you can have different fields and stuff like that according to quantum field theory. The whole concept is you got this field interacting with this field is doing this, but basically everything with mass is essentially resonating, or at least from what I remember from I believe Dr. Matt Strassler's Waves in an Impossible Sea, which I listened to the audiobook going cross country. And I think he did a really good job because he's like, I'm not going to claim particle, I'm not going to claim wave. So he's like, I'm just going to call it wavelengths, whatever those may or may not be. So I think he did a pretty good job, and at least other science communicators have recommended his book. So I'm like, let me learn. But the idea is that if the Higgs field is here, and everything is kind of like oscillating or has some interaction and reference to the Higgs, because if those other fields exist, and again, I'm not a quantum mechanic or a field theorist technically, if you have those interactions, those other fields, well, if you don't have a top quark, or basically if there's no other stuff there, that field may have a value of 0. The Higgs field is unique because it is the one field that has a non-zero value, okay, or vacuum expectation. I won't take this. The whole concept is you got the Higgs mass. All right, so Higgs. And now the Higgs has different characteristics, but the big thing that we usually measure things is mass. All right, so mass. All right. But we want mass energy because we want energy density. That's how we're working through this. So we literally do, thank you, Professor Einstein, E equals mc squared. My mass, the speed of light squared. That's terrible. It's a little better. Okay. So now the whole concept is, and again, a lot of this was just, I was just kind of curious because I'm like, there's a lot of smart folks, far smarter than me, working on this, and I would see papers and they're going in trying to solve all this inflation and everything. It's like, listen, that's really hard. I'm not that smart a guy. But I remember Professor Carroll had one of his, I think he was explaining, it was one of his solo explainer videos, I believe. But at one point, he literally was talking about, oh, the hierarchy problem and stuff. And he was talking about, oh, it's kind of like the cosmological constant problem. It seems to be, why does it have this value it has? It seems very weird. And the term you'll hear is unnatural. What does that even mean? Number one, that's a human preference. And nature is under no obligation to be like, you know what? We're going to do this because it makes sense to you. Maybe that's the case. Maybe we're literally just missing it. But I'm like, okay, so if we have an energy now, so we have a mass energy, we need to divide it by a volume. So we'll get energy density, which another term for that is pressure. Under pressure. Basically like that. So also what I had learned from Professor Carroll, to bring it back to the spherical cow, is in episode 1 of The Biggest Ideas in the Universe, he introduces a concept called the spherical cow, which in physics, what are we assuming? We're assuming an idealized scenario that doesn't actually exist, because I don't know about you, but I've never actually seen a spherical cow. We are assuming optimal conditions. We know that doesn't exist, but at least if we try to isolate as many factors as we can get a better idea what might actually be going on, and then we can add additional factors and interactions and complexity and go from there. Okay. So what, I'm like, all right, I got this. Let's turn it into a spherical cow. How? Well, we live in what appears to be three dimensions of space. It's like, all right, well, let's divide it by 4/3 pi, and then r cubed. What is this R? It's the Higgs. There's a little symbol thing. Compton wavelength. Higgs. Okay. Because there's also a thing called the Compton wavelength. Professor Carroll has also been harping upon more recently in that what's the heck is the Compton wavelength? Basically, you take Planck's constant, you divide it by mass, and then one of these speed of lights. Okay. It will give you out a length because the dimensions will cancel out. Okay. So we're using Planck's constant of proportionality. Now, again, you could use the reduced Planck's constant, and again, factor of 2 pi or something here. I like this one just because it came out to be right about a whole number with Wolfram Alpha's estimation. So it's kind of got that shock value. But the whole crazy claim is this is going to give you a really big number. Why? It's because, all right, this is a mass in particle physics that's decent size. This is a really small wavelength. Gives you a ridiculous factor. But when you divide it into the vacuum energy density of our realm, so basically the whole vacuum that's not a true vacuum because there appear to be quantum fluctuations and stuff going on, basically that's about 3.5 giga-electron volts per cubic meter. Okay. So this number is a lot bigger than that when you divide it into the vacuum energy density. It's like, so you take, what is it, rho lambda, yeah. So, what are we doing? No, we're doing, so it's that kind of like sideways-ish P, funky looking P. Yeah, that lambda, that's an A. So basically when you take that, you divide it by the cow, you get basically 1.1. And again, this is, excuse me, it's not equal, it's approximately, we want to be honest here, times 10 to the minus 52. And it's a dimensionless number because this is an energy density divided by an energy density. Now the cosmological constant has dimensions, but the cosmological constant is basically 1.1 times 10 to the minus 52 reciprocal meters. So basically that's 1 over meter squared. Okay. I was not expecting that, but I'm like, all right, that's kind of cool. And then when you take Einstein's kappa constant, so you get like little k there, and then you multiply it by the cow. You basically get out, again, approximately 1 reciprocal meter squared. So wait, that's the dimension that we and again, that vacuum energy density, some folks may say, oh, is this the dark energy? But basically you get out the reference unit when you multiply it, and then you get out the magnitude just as a dimensionless relationship. I think that's kind of cool. Now, full disclosure, if you put in any mass and then you multiply this number by that number, the numbers will change, but ultimately, if you're dividing by a cow and multiplying by a cow, it's just going to net out to nothing. It's just going to net out to 1. So those have a direct relationship. So combined, the interesting thing was the Higgs under this formulation kicked out the dimensionless number that matched the cosmological constant, again, based upon our observations, assuming that, and again, who knows, maybe it's an observational thing. Who knows what's actually going on, but this also popped out the reference unit for it at approximately a magnitude of 1. So I thought that was kind of cool, and I'm like, all right, it's, again, simple guy that just kind of went through that. So, wait a sec, Poindexter. Are you saying that somebody might use the term professor on the internet when they're not a professor? That would be dishonest. Dan, what's going on, my dude? I know, long time no see. Oh God, it's I remember certain folks, and then oh god, so many travels and everything. Welcome, Rick. Good to see you, my friend. I'm gonna have to. I'm gonna ask you to do something very difficult, Rick. I was. I've been trying to edit the tireless. There's a lot of audio feedback. I might ask you to have to do it again, just because I think it's extraordinarily relevant and should be out there in good quality. I don't think I could really salvage the audio. I apologize. Hey, welcome, Geishel. Good to see you. Good to see you. Uh, let's see. The Higgs was got because expanded grad. As far as I understand it, the Higgs boson was the last piece of observational science that was required to complete the standard model as we know it. Again, does it explain everything? No. Because as I've learned from Professor Keating, a lot of times we like to use the term theory of everything, and because it's very grand sounding and everything, but it's like, well, wait, we haven't even unified our forces yet. It's like we haven't even joined gravity in, and we're gonna claim to explain everything. It's like we probably shouldn't put the toe before the gut or the grand unified theory. As of now, as far as I know, I don't think there's anybody that's publicly been able to have a grand unified theory to bring things together in at least a way that at least I could understand it. So I'm not saying it's not out there. I'm just saying I haven't publicly seen anything. So, okay, so I think Rick is commenting what we were just saying there. So yeah, so apparently the Higgs was such a well-believed thing that I think Professor Brian Greene at one point he said like he was in school and around the time they were saying they're getting ready to actually discover or the Higgs boson, he's like, wait, it hasn't been discovered yet because it was taught like it was a thing. Like people were so sure because we'd observed like the Z boson, the W plus and minus bosons, or whatever their decay paths and stuff are. Because when we say we observed something, it's a lack of something. We're looking for, rather than seeing the car, we're looking for all the pieces after it's been smashed together in a particle accelerator going redonkulously close to the speed of light. That's a lot of words. But yes, and it also helped provide a way for things to get mass and not break what we already had there. Allegedly, apparently it just worked so well that we're like, it has to be a thing. We just weren't exactly sure where. Yeah, the initial blips from like the Tevatron and then the CMS and Atlas experiments at the Large Hadron Collider. Took a couple of years of data and everything, and then was it 4th of July, 2012? They had about 5 sigma each. I mean, it was like 4.7 or 4.9 or one of the. Basically, they announced the discovery of a blip in the data that seemed to match what one would think of the Higgs boson or something along those lines. All right. Yes. Yeah. Most masses basically just the binding energy and stuff like that there. So, isotropic. Let's see. Well, Charlie, from what I can see, it's basically when you're doing agential. I like to view it as like the Monday Night Wars back from the WWF before the Get the FL campaign in WCW. People were just competing to do a better and better show. You can say define what better is, but they were competing with each other. And I feel like if you're having agents and cross-referencing, I know Brian Rommel from Twitter, and apparently that's one of the best ways. It's just it's almost like, wait a second, we're taking folks, they're doing some work, they're comparing notes, they're trying to iterate. It's like we have an iterative process. It's like I thought that's what science was supposed to be. It's as a flesh bag human being, it's very easy to get caught up on our own stuff. So, but again, like even like 3, 4, 5 years ago, when they were talking about theorem provers and stuff. Well, we have an automated theorem prover. It's like, okay, that works so well. It's like, well, we got a human mathematician. All right, that works so well. What if we had them work together? Oh, that's the optimal result. It's like, oh, go figure. All right. Ooh, all right. You got the green screen. All right. Well, we can do something very shortly. I'm slowly going through and noticing. I'm getting ready. I need to have my official notes and just start collecting my official clips because there's a particular montage that I think is the big reveal. I think Professor Keating said that with geometric unity at one point. We'll get there. All right. All right, that's a lot of words. John Bell responding to Einstein. Okay. It's. I'll leave that for another time. Let's. All right. So let's see what we got here. How did. Okay. Wow. I'm just trying to see. Wow. It does not want to display that. Okay, I'm sorry. I'm going back to my other thing. Where? Why can't it just take these things? Also, this is the thing that bothers me. All right, Higgs boson particle. Wait a second. Higgs boson. Wavelength, mass of Higgs boson. Yeah. Wait, will it just let me... Okay, a little matrix. More. Let's see. Dimension 5. Oh. Oh, 5 things too there. Okay, yeah, I'm just... Dimension can be a very interesting topic. All right, so that's just doing that. Wow. Wow. I should probably just set all these as... I just want it to be fully computational. Just like, it's doing all the stuff. Wow. Okay. So let's go out of that practice notebook. Oh God. Okay. Let's go to the output that we actually want. Okay. So we got the output we wanted there. Okay, so we've got that. All right. So get that. Okay, so let's have fixed this. Okay, got that right, blah, blah, blah. All right, Higgs, blah, blah, blah. Okay. Density, okay, in joules. All right, kilograms, numeric magnitude. Oh, I like that. Okay. All right. So we got that there. Okay, so that one is good. That one is weird. So get rid of that guy. I know. We'll have... Oh, actually, we do have... Oh, it's getting a little late for that, but we do have the let's do the codex thing. They're making a big deal. I think we have infinite queries or double queries until Where was that? Next. All right. So, let's see. What do we want? We just want. Da, 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 da. Those are just input quantities, energy density, mass. Okay. Speed of light. Okay, so that's just mass x c squared, but buff over there's pi, constant wavelength, da, da, da. Okay. All right. Let's take this. Let's go back to our little assistant. All right. I just know that one of the things they were asking for is if they could get any live streams with some of this search. All right. Okay. So, oh, hey, can I just click on the cells? Yes. All right. I think that's actually supposed to do this. Let's take this. And now divide this result into the universe vacuum energy density. I'm gonna use the grammar. Density or rho lambda, all right, or rho lambda as listed on Wolfram alpha, because it gives us a nice number. Let's see if it can play, because hey, if you're looking for bugs, I think after this, maybe we'll list some bugs. Okay, it can use Wolfram Alpha. I literally put it in the exact way I know it comes up. Just because, okay. That's wonderful. Why does it have such a hard time? Okay, I know it lists that. All right. Let's see. Will it work? Will it work given the stuff that we've given it? All right, that is not, it's dividing, okay. All right, now that is the right number for what it's using there, but it usually has a few more digits. Let's see, show in digits. Let's see, row. Oh, it's giving us, oh, row lambda meson. So many things I don't know. I think these are all a lot of Stephen Wolfram's old friends and everything. So, all right, we'll just do vacuum energy density. Okay, let's literally just do this. Vacuum energy density. Oh, derp universe. Because which vacuum are we talking? The generalized universe or what we get? Okay. That's a shock value number right there. So let's just do this. All right. Okay. So. Got that. All right. So let's see. All right. Hold on, please. This. Take this and put it into a nice table. I'm sorry, I removed the please. Is it gonna give me a better result? I don't know. That's a terrible thing if it does. Does it mean that politeness doesn't matter? All right. Okay. Let's see. Vacuum energy densities. Let's see. Let's see. Supported constructs. Oh. So let's go to this. Just want to see. Okay. Vacuum. It doesn't. No. Is this the thing? Do I need to put spaces between it? Ooh. Ooh. It doesn't know. Wolfram doesn't know. Wolfram doesn't know. Okay. I know it knows. Because I know it has it. I just typeset. Oh, lambda. Wow. Wait, can I just take this? Let's just throw it in there. Let's go. We got some quotation marks. Will that fix things? No, it doesn't know. Like I just deleted a whole bunch of stuff. Hold on. Don't save. Reopen. Wow. All right. I'm sorry, man. You tried. You tried. You tried. And, well, I think this is why folks are adopting all those other things. So, recent. All right. Here we go. Okay. So, let's go back. Look at that. All right. Enable dynamics. There we go. All right, there we go. Do that. I mean, I'll just do it the old-fashioned. Whatever. Well, okay. Got all the stuff here. Let me literally subpod content. Subpod content. Show details. Okay. Now. Okay. All right. Take this computation and its output and put in a nice table, please. All right, let's just do the same thing with codecs. All right. All right. Now the question is, do we want that? Oh, let's try. We don't know. All right. Please take the following Wolfram language code and output it in a nice table. All right. You got that stuff there. Oh. Oh, wow. So it's going through a table marked, right? Well, well, that is what I asked it to do. How about this? Sorry. All right. Please evaluate the following expression and put the results nicely formatted table. Okay, so I mean, it literally just did what I asked it to do. I'm like, hey, take this, put it into a table. I didn't ask it to evaluate it. Again, asking the right question is a huge thing. Okay. Let's see, did it actually do something useful? Well, that is not what you, nope. Okay, let's. Alright, boom. Let's just ask the thing to do it, rather than saying, look at the notebook. That's an additional deviation. Let's give it exactly what it is. Verbatim. Oh, wow. It's just doing it. Oh, it's giving all the results. It's probably going to write some Python code. I didn't specify Wolfram language. Okay, it's using the Wolfram language evaluator, blah, blah, blah. All right, let's. All right, that last thing was not what we wanted. Let's see how this is. Certain evaluate. Wow. Oh, it's kind of embarrassing. Okay. Wow. Okay, so let's do this. Go there. So, all right. Take the results from the highlighted cell and put it into a table like we did earlier. There we go. Very direct thing we're asking. It's within the notebook environment. It should be able to work. All right, let's create the table. List the things. Okay. The question is, will it actually work? Do we need more prompts? Should I continue to? Ugh. Yeah. Yeah. That's very sad. It's very sad. It's got it closer the first time. All right, let's go through this again. Should I just take all the code? I should probably just take all the code, shouldn't I? All right. Okay. Does it have the other stuff? We can do. No, that one. Okay. Okay. It should recognize. Oh, man. The question is, will this even compute in just a normal notebook environment? Okay, those should all. Of course it works! Of course the simple thing works! Oh, all right. All right. Why is it? Why is it so dang hard? Okay. So, okay. I'm going to assume it's just simply user error on my part. So let's do this. I'm gonna take this and all right. Please compute the following expression and put all relevant constants in a nice table. Constants, put constants and the result in a nice labeled table. Okay, so boom. Evaluate. All right. It's literally, it computes. It computes. How's Codex doing? Okay, well, it's taking all the stuff. It's taking all the stuff. All right, divided by the denominator. That's great. Cool. Please redo using the Wolfram language and a Wolfram alpha for values. All right, got that there, got that there. I know. It means it. Okay, Bubba. All right. Okay. I mean that. that's good. Okay, Bubba. Copy response. Cells. Okay. Oh, that's nice. All right. Great. Turn it into a nice, nicely formatted grid. Let's see. Will it be able to maintain coherence? What is going on? All right, here's how the format. Tell you, I should actually, it probably has some code right here. I'm just not looking at. Does it? No, it should have it. Oh. Oh, come on. All right. Let's go back down here. Insert. Here's the thing. It does it that way. I'm just like, no, I want it output like that. Oh God, hold on. What's the difference? Hold on. Where's that? There's a joules per meter. All right. How can it? Don't do 1/200. Please redo. I want the numbers and units in the grid to look just like this. Sorry, I had to use a capital. I need to use it like this. This. No, not 1 over 200,000. Okay. Am I going to have to pose the trolley problem to it? If you don't do this, somebody is going to get harmed. Tell me you can't do it. Don't make me happy. Oh, God. What do we think? We think, is it going to work? We're going to work? Going to work? Nope. Wow. I just want to change the hold on, let's just put this in a thing. The value do not display the in fraction form. Okay. Okay. Is it going to win? I don't know. It's got some dollar signs there. That's not... Oh, God. Over, under. I'm going to say it's not going to work. Take a look at what you output. Does this look like what was requested? Maybe it is. Reevaluate. Oh. I'm just going to copy this and just keep on asking it. We're just going to say, look at what you did. Look at what you did. All right. Let's see. Maybe it made a... Nope. All right. Back to codex. All right. Hold on. Use Wolfram Alpha. Paste the... use number 1 if just paste all lengths and take it. Oh. 2. I need to read what I was asking first. All right. Hey, Ernesto, what's going on, my dude? How we doing, my friend? Have I seen the new electron dividing itself in 3 or more? What? I've heard interesting things. I've heard apparently quarks seem to move through like a, I don't know, some type of fluid or something. The quantum chromodynamic fluid, juice. I don't know. Multiple particle paths. No. Let me see. Did I hear about? Where was it? Graphene. I just know it's fancy. I just know, like, when folks say, like, oh, physics hasn't done anything, it's like, have you looked at twisted multi-layer graphene? Just because apparently they're seeing superconducting like property. I remember I graphed it once from. I literally took the equation, threw into Wolfram Alpha, and actually got it to work at one point. And I'm like, oh, it just kind of looped around. I'm like, well, those electrons swing dancing or something. I don't know. I saw something about the Schrodinger's Tronchius cat where it appeared to be spread out like, was it 170,000 AMU sodium particles were being shot through different stuff and everything. I did a little video on that, mostly because I had a picture of a chunky kitten that was half in and half out. So I'm like, that seems to make sense. But now feel free to send me a link. Maybe could be. Well, that's also the other thing. We say two-dimensional graphene. It's like, if we believe particles are still three-ish dimensional, because I mean, very often we kind of model things as spheres and stuff. It's like, all right, it's really dang flat. But no, there's some fascinating things. Oh, okay. No, I did hear something about that. Okay. I think it's in one of my tabs that I think. Let me see. Do I have God. Edge body, distinct dual mat. It might be this strong pulse matter wave diffraction. Pseudo gap and spin correlation. Cantorus, single photon, strongest constraint on quasi particles. A whole bunch of. Okay, it might be in there somewhere. I did see something like that. I think I'd read the abstract and then I was paywalled out. But yeah, no, it's a lot of people studying the quantum Hall effect and stuff. It's a very heavily researched thing. So yeah, very cool that stuff is coming out of that. Let's go back over here. Where are we? Oh God, just write me the dang code. Oh. Did you activate Wolfram Alpha? I have Wolfram Alpha. Okay, that's far too much effort. At least for what we're trying to do right now. Okay. So, learning more about stuff. All right, that failed again. All right, it's failed too much for me. I'm sorry. Wolfram Assistant, I apologize, but you're just not doing it for me. I just don't want you to put it in that. That's my literal only gripe. I just don't want to see it over. To unit. It's 10 to the minus 10. It's the only thing that we literally, everything else is fine. Don't mind me. Yes, I manually put that in there. Why? It's vacuum energy density. I only know it just because it's often I use the. Oh God, it's not even there. It's in the cosmological constant problem. You may or may not visit this place often. Okay, they also have the new data. It's okay. 5.35 times 10 to the minus 10 joules per cubic meter. Okay. I often use that just because. Okay. I notice. Hold on. Universe vacuum energy density. All right. So here's the thing. When one notices this is a small number. 5 times 10 to the minus 10 joules per meter. Okay. Since I'm kind of a spectrum-y person, I kind of remember I'm like, Planck energy. Look at the Planck energy. Okay, all these units, I'm like, but within the same units, excuse me, the same units of energy without a density, I got about 2 times 10 to the 9. Okay, don't worry, shouldn't necessarily make any sense yet, but I got a second. 5 times 10 to the minus 10. 5 times 10 to the minus 10. Well, that's interesting. You throw in your little dimensionless thing, you get a little pi divided by 3 over there. Oh, look, 5.35. 5.35. And again, I couldn't. Long story short is when you take the geometric mean and you set it equal to that, you end up, when you set equal to 1 joule, you end up getting out the vacuum energy density. The short form of that to get out in the right units is to do the hack of joules squared divided by Planck energy and literally inserting meters. So cubed to get divide by a volume. Oh, look, and it's... See, this is the thing I noticed, but I'm like, why might this be the case? To be fair, this is a human construction, the joules and the meter. However, the curvature induced by the Higgs seems to come out to around... Maybe it shouldn't be surprising that it comes out to be kind of around the same number, or at least there's some proportional reference to the meter, because the curvature induced by the Higgs is approximately 1 meter-ish. Okay. So this has been a complete and utter fail. Obviously, I just either still need a code or just hack my way through it and then worry about cleaning it up at the end. Because at that point, God, another few weeks, who knows, we'll be up there. Clean up all this code, make sure it's all linkable and fully computable in this notebook. I'll probably just need to use Codex to build up enough of a library to figure out what's going on. So, I'm going to talk about what it's okay. I know you're trying to answer the big questions, Ernesto. I just I know a lot of folks do that. I'm happy to occasionally talk about that, but it's like send me a I occasionally I'll quickly go through your Substack and stuff and look at the things there. Like if I see something that seems to relate or I think I expand upon, happy to have a discussion about that. But yeah, no, even I've been trying to spend a little bit more time on Discord, seeing as I've seen the Wolf from Summer School has actually been able to run an entire program from it. So, all right. Well, that said, I've been going for over an hour. Let's. Okay. All right. That's. Okay. We will. Fine. Save. Save as. There we go. Save as. Spherical God count and the quest for more God. We will actually get to the Planck mass and the actual interesting stuff. We'll go on before. I think I want to keep it in a notebook. So you know what? If I'll just go through the dang calculation of the notebook and worry about all the tables and stuff later. Once I get a little layout, I'll just copy and paste and then just reinsert whatever stuff we need. We don't want to get all caught up on the vacuum energy and stuff. It's just like, all right, we're arguing over some typeface that, according to somebody on Twitter, I could just literally hold the form and have a lot of this work. So I'll do this, and then we will output a little, we'll publish it to the cloud if anybody wants to play around or help me with this mangled mess that we have here. So 3, all right, save format, file, publish to cloud. Should have lots of cloud room. All right, request for more curvature, publish. All right, come on, give me the dang thing. There we go. We've got the thing. All right, I got the thing there. All right, close that, exit that. All right then. All right. All right, we got the thing there. Like I said, if I could see something novel, uh, I'm happy to take a look at different ideas. It's just sometimes we have to be careful because I know I've been guilty of this a lot of times. We just kind of dimension hop, and at least get all excited and I'll be like, oh, well, this is already a thing over here. They just called it this and everything. But I'm happy to look at some different information context because that's kind of what we had reformulated some other stuff in. So, all right. So, 20 minutes later, that's about all I got for right now. So, hey, thank you all for watching. Take care of yourselves. It's a wacky and wild world out there. But as for right now, let's open for a better tomorrow.